Hey, what's up everyone and welcome to Daily Code Buffer. In this video, we are going to learn about the Streams API of Java 8. Stream API was introduced in Java 8 and after that, it has changed the course of how we do the Java development. It has changed the complete imperative style of programming into the functional style of programming. So in this video, we are going to learn about how we can utilize Stream API and how it is useful to use the Stream API rather than traditional for loops and all those imperative style of coding. So without any further ado, let's get started. So let me just start the project over here in IntelliJ IDEA. I'll just open the IntelliJ IDEA here. And here I'll create the new project. I'll just name Stream API tutorial. And I'll just give the name as group name as com.dailycodebuffer and package name as Stream API. These are just the basic details, nothing else. I'll just generate the basic project of Spring Boot. You can create a basic Java project as well, basic Maven project as well, just to understand what is Stream API. This is quick, so I'm just creating this project. So we'll wait until the project is ready. Let it load everything. And here you can see that this is your project, this is your main file, you have your main method here. And here what we will do, we will go through the bunch of methods available in the Stream API that we can utilize and how to get our desired outputs. So what we will do, we will work on a list of object over here. So the object I'm going to create is the employee. Employee will have a bunch of fields and we will create a list of employees and we will be doing the operations on top of that list. So first let me just create the class over here, employee class. And let me just add a few fields here. I'll just add private string first name, private string, last name, private double salary, and private list of string projects, which projects they are working on, employees. Okay, so these are the fields. Now let's create the getter setters. I'll just create the getter setters for everything and I'll create the constructor with no arguments and I'll create a constructor with all the fields as well, and I'll create one toString method as well with all the fields. Okay, so my basic Pojo is created of employee. Now I can list down all the employees. I can get the data from the database, or in this particular example, we will just hard code everything to have a list and we will do operation on that using the Stream API. So let me just go to the Stream API tutorial application.java where our main class is, and here I will define static list of employees equals to new array list. Okay, and in the static block, let me add all the employees. So what I'll do, I'll add employees dot add new employee, and I'll just give the name Shabir Daudi. Suppose the salary is 5,000 rupees in double, and then I'll add the project. So I'll just add list of project 1 comma project 2. Okay, one employee is added. Let me just add the another employee as well, employee dot, and here I'll just change the name. I'll just add Nikhil Gupta, and here I'll add Shivam Kumar, and here I'll change the salary from 5,000 to 6,000, and here 5,000 to 5,500. I'll change the project details, project 1, project 3, and here project 3 and 4. Okay, so here you can see that we have an object list of object which have different types of values available. We have the strings for first name, last name, we have a double salary, and we have a list of string as well within the object. object. Let me just correct it here, Shivam, and here I'll just change Kumar. Okay. Generally, this type of object you will be working in the real application where you will have a bunch of different collections and bunch of different data types available for your object, and you need to do some operations on it. Ideally, what you will be doing in the imperative style of programming is you will be running through a for loop or a do while loop or a while loop, and you will be doing some operations on it. But with the Streams API, you can do even much better. Stream API consists of different methods available. Those methods either would be terminal methods or terminal operations, or it would be intermediate operations. Those operations you can do on a collection that you have, and based on that collection you will get a desired output. Whatever the output you want, you can get the output back from the stream. And it is also lazy in nature, so until and unless a terminal operation is been called, the other intermediate operation won't be executed until they need the proper data. So it would be much faster in implementation rather than your imperative style of coding. So let's start with the examples and let's see what all things that we can do. So here, let me just comment it out here. And to create a stream of object, what you have to do is you have to use the stream interface. Okay. And if you do stream.off, and you can pass the collections or values here. If I am passing employees, then I'll be getting the stream of employees here, stream of list of employees here directly. Okay, and if I print it, I'll get the object here. So this is how you will be able to create the stream using the stream interface. But ideally what we'll be doing is we will be calling the stream method on the collection itself. So that also we will be able to convert to the stream. So rather than doing stream.off employees, we can also do employees.stream. So this is also, we will be getting the same result. So what we did is we are changing our collection to the stream. Stream is nothing but it gives us the abstraction to work on. It is not now a collection object, it's now a stream object. Whatever operations that we are going to do, those all operations will be on the stream, and at the end, whatever the collection or whatever the data type you want, you can get the data back. So the most basic thing you would be doing is using the for loop, using looping through all the elements. So let's do that first. I'll just define for each here. So what we will do, for employees.stream, we'll be doing for each. Okay. Now for each is a terminal operation. So once you do the for each, you cannot do any operation after that. Now for each, you can see that it takes a consumer. So it's going to consume any data and it will do some operation on it. So you can see that we have to use the Lambda expression over here. So for each of the employees we have, that is a list of employees, it will take each element as the input. So you can see it will take employee here, and for that employee we can do any operation. Suppose if I'm doing just printing out here. Okay. So I'm taking the employees here, that employees is converted to stream. For each element in a stream, using the for each loop, it will take each employee and I'm doing any operation over here. Simple thing, simple for each. If I run this, you can see that I'm getting all the three objects, that is Shabir, Nikhil and Shivam. Cool. Okay. Now let's add any intermediate operations on it. So the basic intermediate operation that you would be doing within this stream is using the map. So what map does is it allows you to map a particular object into a different type of object, and it will return the stream at the end. So let's take the example of map here. So what I'm going to do here is I am doing employees dot stream, and here after that I'm doing the map operation. Okay. Map will take one object and it will give the another object to you, whatever the mapping here you want to do. So what I want to do here is I want all the employees here, whatever the employees, and for each and every employee that has been given to me using the map, for those all employees I want to increment the salary by 10%. Okay. So at the end I'll be getting the employee back, but the salary component will be changed to increased by 10%. Okay. So what I'm going to do here, I'm getting the employee, and for that employee I am creating the new employee object, and for this I'm getting employee dot first name, employee dot last name, employee dot get salary into 1.10. So I am increasing the salary by 10% here. Then employee dot get projects. So here you can see that I converted into map but if I just end this operation here, it will be just giving me the streams. But at the end, I don't want streams, I want the data back into any of the collections. So this time you can use the collect method. So let me just comment here that we are going to use the collect as well. So what I'm doing is, after this operation, after this map is completed, we are doing the chain of operations. So after this, again we can do chaining of operations, and I can do collect. What I want to collect, I want to collect this data into the list back. So here you can see that this is the method that is taking the collect, and collectors.toList it is doing. So the entire streams it is going to collect back into the list. And here I can take the list of employee back. List of employee, and I can say increased salary. Okay, so what I did, I took the employees and I streamed through it, and then I did the map operation. That's the intermediate operation. I took each and every employee and I created a new object. For each new object, I just incremented the salary to 1.10, that is 10%. And then at the end, after this operation is completed, I am collecting back all the data to the list. Okay, and then I can do s out increase salary, and if I just print this, you can see that everyone's salary has been increased. You can see that earlier it was 5,000, now it is 5,500, and so on. For Nikhil it's 6,600, and for Shivam it is 6050. Now the other thing you can do is you can take this data into set as well. Now if you don't want into list, you can convert it to set, and you will get the data into set. And here I can change to set. Okay, so collectors you can use this way as well. In whatever data type you want, you can get the data back. Now let's check one more operation, that is the filter operation. Filter operation is nothing but you will do if else loop to filter out some of the data, right? So that we can do using the filter operation. So what we can do here in the previous example, we incremented the salary of each and every employee. But now what I want to do is I want to increase the salary of the employee whose salary is greater than 5,000. Okay, so I want a filter operation on that. So simple, I'll do of employees dot stream dot filter operation. Here you can see that filter is taking a predicate, so it will be executed based on the true or false value. Okay, again it's a lambda expression always, so we will be taking the employee, and we will check the employee dot get salary should be greater than 5,000. Okay, if any employee's salary is greater than 5,000, those only will be passed through it, and the next operation will be performed on it. And then again, once that is done, I want to do the map operation. You can see that filter is also the intermediate operation, map is also the intermediate operation. Now how you will get to know that which is intermediate operation? Any operation that is returning the stream itself, that's the intermediate operation. Okay, so filter is also returning the stream object. You can see that it is returning the stream, and map is also returning the stream. Okay, so here we will do the map operation again, and map operation you will do the same thing. So I'll just copy this. Okay, and here you can see that we are adding the chain of operation, like what all operations that we want to do. And after that, I want to collect the data back to the list. You can see it's simple. Now if I get the list of employee here, filter employee, and if I just print this, you can see that I got two results only, that is Nikhil and Shivam, only two. Shabir is not there because its salary is 5,000. We want only salaries greater than 5,000. So you can see this way you can add the chain of operations and how the filter is working. Within this filter we will add one more operation, that is the find first. Now what find first will do is it will get the first element out of it. Now rather than doing this collect, let me just copy this so it's better. So this operation we did here. Okay, and I'll just change to first employee. Now rather than taking all the data into collect all the employees, what I want is I want the first employee whose I have increased the salary. So after the and find first is the terminal operation. So after the map operation that I have done, I want to get the first employee. So I can just do find first, and here you can see that find first returns the optional of employee. Now optional is something that requires its own video, but what optional will do is it will optionally send the value. It might have the value as well, it might have the employee object as well, or it might not have the object as well. Anything can happen. So it's returning that optional. So for this optional we have to check that also, like if there is a value within that optional, that's fine. If there is no value within that option, I want to do some other operation. I want to throw an exception, or I want to get the any dummy value, or I want to get null. So here what I'll do, I'll just define that find first is optional if there is no value, then or else I can define or else pass null. Okay, and here this will be the employee, not the list, because we are just getting one value. Okay, so if I print this as out first employee, you can see that I'm getting only Nikhil Gupta. Okay, only one. You can see only one is there. Now if I change this value, like I want all the employees greater than 7,000, then at that time this or else will be executed and I would be getting null. You can see that I'm getting null object here. Okay, so this way the optional will be written, and you can use or else or else get or else through method to do any operation that you desire. Now let's see another operation, that is the flat map operation. Flat map operation is nothing but to flatten up the object that you have. Suppose you have the list of string, and if you do the flat map operation, you will get a stream of strings only. You won't get a stream of list of string. If you have a list of strings, you will get a list of strings. So one data type that you have that is containing it will just flatten out that particular data type. Let's see that in example. So what I want is I want employees. So what I'm trying to do is I'm trying to get all the projects that I have, right? So all the employees have a list of projects within that particular object. But what I want is I want that entire list directly. Okay, direct strings directly I want. So what I will do is employees.stream. Then what I'll do, I'll just map everything. And what I want is I don't want the entire object, I want just a list. So from that entire employee object, I'm just getting the employee.get projects. So at this particular point, this line number 87, you will be having the stream of list of employees. But after this map operation, you will be having the stream of list of projects. Okay, because we map our employee object to the list of projects. Then I am doing flat map operation here. What flat map operation is happening is all the strings that I have, right, that I want to convert to strings.stream. Okay, so here the list of strings will be converted to just strings, and then I am going to collect all those values dot collect. You can either collect in the list as well, but what I want to collect in a string. So what I'll do collectors dot joining, and I want to join all those values by comma. Okay, so here I want to do is stream. This entire list of employee object is now converted to the string that have the list of projects. So here I can take string projects equals to employee.stream, and here you can see that you are seeing everything. At this particular time it was stream of employee. After this map operation, it converted to stream of list of string. After the flat map operation, it converted to stream of string, and then we are collecting all the strings separated by the comma operator. Okay, and if I do s out here and just print projects, I'll be getting all the projects separated out by comma. So here you can see that I'm getting all the projects separated out by comma. Cool, right? Now there are short circuiting operators as well available. So what short circuiting operators will do is it will limit your data. Okay, so let's see that. So let's just define short circuit operators, short circuit operations. And here what we will do is, let me just grab the employee lists, and then if I stream through it, now what I want to do is I don't want to do any operation on the first element. Okay, so I can just skip that element, skip one, so the first element would be skipped. So you can see that we are just short circuiting it. For first one, don't do anything. Okay, and then what we are doing is we are also adding the limit to only one. So that means skip one, then take the one, means whatever the limit that we are setting it, and then rest of the elements are skipped directly. Okay, then collect all the elements. You can see it's very simple. Let me just grab the list of employees here again. This is a list of employees, and I can just say short circuit. Okay, and if I just print out and run this, you can see that I'm getting only one employee, that is the Nikhil. Okay, no other employees. So you can see that we short circuited the data. We just bypassed the first element and we took only one element out of it. Okay, now the next thing that we can do is we can look through the finite data. Okay, suppose you have a list of data that is infinite, and if you want to convert to finite data, that also you can do using the limit itself directly. So what you are doing is, if you have stream.generate, I'm just generating the random value. Let me just do math random. Okay, I'm just generating the random value over here, and it will just loop through. Okay, so what I want is I want to limit to only 5. Okay, so it's converting my entire loop to only 5 elements here. And then what I want to do is for each of those elements, I want to do S out. Okay, so you are just converting your infinite data to just finite number of data. And if I run through, I should get the result back. You can see that I'm getting 5 records over here. Okay, so converting to finite data as well. So this is all operations that you can do. The next operation you can do is sorting as well. So always when you do sorting, you will need to use your comparators or comparable that you can use within the stream as well. So let me just define sorting, and let's see sorting. So what I want to do is I want to sort my list based on the first name itself. So I'll just define employees dot stream dot sorted, and here you can see that this sorted is taking the comparator. So within this sorted, let's take the comparator. It will take the two values, and it's a lambda function. So we'll just define o1 dot get first name dot compares to ignore case o2 dot get first name. Okay, so this is just a sorted operation that we did. And after that, once you do the sorting, if you want to collect, you can get the data collected back to your list. Okay, you can see whatever we are doing till now, all its chaining operations, and either we are doing the intermediate operation, and at the end we are doing the terminal operations to get the data back. And once this is done, I can take to the list of employee sorted employees equals to this. And if I just print this value to sorted employees, I'll be getting all the employees which are sorted by the name. So first is Nikhil, then Shabbir, and then Shivam. Right? All the values are sorted according to the comparator that we have provided here. Now the next thing that we can do is, if you want to get the minimum or maximum number of data, what's the minimum or maximum value, that also we can get based on the stream. So suppose I want the maximum salary out. Okay, who has the maximum salary, that we can get using the max operator. If you want minimum, you can use using the minimum operator. So what I'm doing here, I am looping through the employees.stream again, and then I'm doing the max. So you can see max is taking a function. That function needs to be executed based on that we are going to get the data. So within this max function, what I'm doing comparator.comparing. Okay, if you want any comparator, you can use the comparator, and you can see comparing is again taking a function. What I'm comparing based on is employees salary. Okay, and this should be max, not map. Okay, and this will again get you the optional. You can see that it will give you the optional. So as earlier we saw the optional, we can, at that time what we did was we did the or get, so we took the other value. But now suppose if that value is not present, I want to throw the exception, so I can throw exception as well, or else throw, and here I can define no such element exception new. Okay, so this will give me the maximum salary who have based on the salaries that is provided in the object. If there is no object available, it will throw the exception. Simple. Okay, so this way you can get the min or max as well. Now the next one is the reduce. Now reduce is something to convert or to accumulate everything. Suppose you have the entire list and you want to accumulate every data, suppose each and every list. In our case, employees have the salary. Okay, all the objects of employees have the salary. And if I want to accumulate each and every salary to a total or to a multiplication or to any value, that is something that I want to accumulate. That type of thing I can do using the reduce function. So let me just give you the example, like all the salaries are being accumulated to sum. So I can just simply define all the employees I have, stream through all the employees, and do the map operation. And what I want here is, rather than the entire employee object, I want just the salaries of the employee. So I'll just take the employee here and I'll just pass employee.get salary. Okay, so now when I do the reduce operation, I'll be only working with the salary part, not the entire object. Now reduce will take two things. One will be the accumulator value, that is the initial value. So I'll just pass 0.0, that is the initial value, and after that it will take the binary operator. What we want to do, so we want to sum up everything. So I'll just define double of sum. Okay, sum each and every values that you are getting. Okay, and here I can just define double total salary. And if I print the total salary, I'll be getting all the total salary of the employee. You can see that I'm getting 16,500. That is the total salary of 5,000, 6,000 and 5,500. So you can see that we see a lot of operators. These are the general operators that you will be using day to day when you are working with the streams. There are a lot more other operators as well. If you just go to stream dot, you will get a list of operators. You can see that you have map, reduce, filter, skip, limit, reduce, and you can see all those will be taking a different types of input parameter. You can go through and you can learn all those things. It's very easy to implement. Once you get the understanding how to write your functional code, it's very easy to implement it. Okay, you can see that there are a lot of methods available and all those methods have a proper documentation as well, so you can follow along. You just have to remember that whatever you were doing earlier, like in the imperative style of coding, that's completely different than what you will be doing in the functional code. At the first, it will be difficult for you to understand what you are doing. It will be trickier as well to implement at the first, but once you practice it, once you start implementing with this, after a few days you will get more understanding on it, and you will be always go with streams rather than going with the imperative style of coding. Now if you want to do any parallel operations on it rather than sequential operation, you can convert your stream into parallel. If you just convert to parallel stream, your entire stream will be converted into parallel operations. Now once you do this, you need to make sure that whatever operations that you are doing, those are thread safe, and all the thread safety and all the thread checks that you have to do in your application that you are doing. Okay, but if you have the need, you can do the parallel stream as well. Now the other advantage you will get using the stream is the lazy implementation. So until and unless the data is being needed by the operators won't call those functions. So suppose if I take this example, suppose, okay, this short circuiting example. So what it is doing is it just converted to stream. So suppose you have 3 elements, after that it skipped that element. So first is skip, and then you are doing limit. So you can see all these operations are not going to perform until and unless this terminal operation is been called. Okay, and this terminal operation is been called for the data that you have left off. So suppose the skip operator is there, right? So it's skipping first operator, and this limit operator will only get the limited data that is been performed by the first operator. So suppose if you are doing filter operation, and if you have 1000 records and filter is returning you only 20 records, so the next operator will only work on those 20 records itself. It's not going to again work on all the 1000 records. If you do imperative style of programming, that's what you will be doing in your for loop, right? You will loop through each and everything, and either if you want to do that kind of thing as well, if you want to just limit down to only 20, you can do it using the break and continue everything, but this is more cleaner way, and this is what you will understand easily once you go through the code as well. So just go through Stream API, just start using it. It's very easy to implement once you get a hang of it. So in the starting, I'm sure it will be difficult for you to implement. It was very difficult for me to start implementing, because every time you have to go through Stack Overflow or Google to how to do this. That's fine. That's the initial step you have to do. So that's what I wanted to say regarding Stream API. Just go through it. If you have any doubts, do let me know in the comment section below. I will try to help you out as soon as possible. If you like this video, give us a thumbs up and subscribe to my channel for the upcoming videos. You can also join my channel and support me as well. And if you are interested in learning Spring Boot and microservices, then these are the videos that you can check that out. I will see you in the next video. Till then, happy coding. Bye bye.